It's okay. So this is the setup that I brought with me to Hawaii. This was our Christmas light setup. So this was attached to our balcony, which the hotel staff told us we were not supposed to have because you're not supposed to hang things off the side of a hotel.
Oh.
But then but it's so Christmassy, so go ahead and leave them.
But it's awesome. So
It's
don't worry.
awesome.
Yeah.
So this is what it looked like. It was powered by a single 1,000 milliamp 3S battery.
Which will charge it for a while, right?
We'll actually run this for like 20 hours.
Yeah, that's pretty cool.
I mean, there's no trouble whatsoever. I put it into this waterproof case, so I made it water resistant because it does rain a lot in Hawaii.
Makes sense.
And these are already water resistant. So this was pretty much a watertight package. I wouldn't take it underwater.
Yeah, but
it was
good
just
enough
fine.
for holding it outside. Yeah.
Exactly, for a balcony. So this is what a typical setup will look like. This is a strand of, these are not WS2812s, which is what we've been using. These are WS2811s. A bit more robust, use up a tiny bit more power, but they're perfect for Christmas lights.
Yeah, they're really pretty.
Exactly. Now this is an Arduino that's running some software that I actually wrote. It just takes it through some of the fast LED display modes.
Right. So is this the code that you went over that one episode that you kind of modified?
Precisely. Now if you look inside here, this is actually really, go to the overhead. This is a super simple circuit. So let me show you the things you don't need. This is just a battery eliminator circuit. It takes whatever voltage I give it. I can give it between 7.4 volts and all the way up to 18 volts, and it will convert it down to 5, which is what I need for both my lights and the Arduino.
Right.
Right. And then this is a filter circuit because I did not want the Arduino and the lights on the same circuit, because what will happen is this will actually draw, the strand will draw differing amounts of power depending on what colors are being displayed.
Right.
I didn't want that voltage fluctuation to be pushed into the Arduino.
And that could either reboot the Arduino or even break it?
Or even, yeah, you could kill it. I mean, if you give it dirty enough power, it will kill it. So what the filter did was, it takes the power from the battery eliminator circuit and then breaks it off into two pieces. So the pre-filter goes to the lights, post-filter goes to the Arduino.
Yeah, then you don't have any conflict.
Right, no conflict. It's still running off of the same power source, but it keeps it a little cleaner. By the way, I know we're not supposed to mention quadcopters.
Quad what?
Quad multi-rotors.
Yes.
But this is actually the way that you would clean the power going into your FPV system. If you didn't want all the interference, the EMI, from the motors making its way into your transmitter, you would put one of these circuits.
Because as you give the motors more throttle or decrease throttle, it's drawing different amounts of power, and that would mess it up?
Well, we've all seen that. When you run an electric motor, you start to hear static.
Yeah.
That's EMI. That's electromagnetic interference.
Okay.
This is a good way to filter out. Okay.
Cool.
But let's look at the circuit itself. Super simple, folks. So this right here, this is red and black. These are going to the VIN, and ground. This is what actually powers my Arduino. I could power it off of the USB port, but instead I've got 5 volts going in right here.
Right.
Okay. Now, I need to provide power not just to the Arduino, but also to my strand, and then I need to connect it digitally to this board, because this board
is
these
sending the
pins
signal.
over here, precisely. So I need two things. I need power for this, and I need digital connection and a ground on the Arduino.
Right.
Okay, so this is what happens. This little strand right here, you'll notice there's actually 4 wires. This is power, so this is providing it power. This is just 5 volts straight to the strand. This is ground and the digital lead.
Right, so there's 2 separate connections. Okay.
There's 2 separate. Well, see, this is what freaks people out. The ground is actually the same. So the ground providing the power to the strand, and the ground providing the other side of the digital lead, it's the same. It's the same ground. I just have them split off for ease of connection.
That makes sense.
Okay.
Why would you want to do multiple grounds?
Well, because you need one ground that's used to provide power for the strand, and if you don't have a ground, like let me remove the ground pin. If I remove the ground, this is just going to keep doing what it already had in memory. The strand is never going to receive another proper command from the Arduino.
So it doesn't refresh?
It doesn't refresh. So it's just doing what I told it to do, but it's not going to receive new commands. Get back in there. There we go. See, that's what it should have been doing. So what I'm going to do is I have ground going to the strand, and then from the strand ground to ground here.
Back to the board.
And to digital pin 13.
Oh, okay. Cool. So
yeah.
that completes the circuit.
That completes the circuit. So I know this is sort of confusing to people who are not at this level, so let's break it down even further.
Sure.
Let's go away from my Christmas lights and let's go to a standard prototype kit that we've got from the Arduino so we can see exactly how it works. So we've got a bare Arduino right here.
Okay.
So this is an Arduino. This is a breadboard.
On a 3D printed little
on a 3D printed little slidey thing.
Yeah.
So what we're going to do is we need a way to bring power to here so that I can power any objects. Like, for example, let's say I want to power this strand of lights. Actually, let's use this one.
Boop. Ah!
Yeah.
Jeez.
The strand of lights.
Easy there.
So what I'm going to do is I'm going to use jumpers. Now these are really simple. I bought a ton of these. In fact, there's going to be a bunch of these down in the no hole, and they typically look like this, which is to say a mess.
Yeah.
These are all the jumpers I have.
But great for breadboards.
Great for breadboards. So I want a red one and a black one if I can find one. I can't.
Well, there's a red and a black one already attached. Oh,
yeah,
no, there's 3 attached.
So I messed up. So I'm going to bring it down. So from ground, this is, see, I wish the camera could get in tighter here. Alex, can you zoom in on that one? See, that says G and D, that's ground. Mm-hmm. VIN, that's voltage in. Now, voltage in and 5 volt are both the positive side. So I could take from either of those.
Okay.
In this case, I'm going to take from 5 volt. So and I'm going to take the ground. Oh, let's actually switch that.
This is taking the power that's going into the Arduino and putting it out into the breadboard.
Putting it out so I can power something else. So let's see if I can get a better angle there. What you can see is I am actually taking 5 volts and ground, and then I'm going to put it into this breadboard right here. So on this side, I've got ground, and on this side, I've got 5 volts.
Now, how do you know where to put it on the breadboard?
Anything. So the way breadboards work is that entire row are all connected.
Oh, okay.
So now anything I plug in here or here is going to get 5 volt ground, 5 volts.
Ah, okay.
Okay. Now, if I give this an internal, if I give this voltage, so I'm going to plug this into my computer. So I've got 5 volt power going in through the USB port. This is now taking that 5 volts and it's pushing it back out here.
Into the board.
Into the board, which means I can now take something like, where did that go? Didn't I?
Oh,
the thing I just pulled out.
Yeah.
This is a standard pixel string, so it needs ground, it needs 5 volts, and then it needs a digital pin. I can now take this is the positive side, I can plug it into the positive side there. I can take this, plug that into the negative side there. And now this is my digital pin, and I could plug this in, say, digital pin 7, 3, whatever it's going to be. It won't light up because I have no logic in there right now.
Right, that's just what you use to send a signal to control the lights.
Correct, correct. So this is a complete circuit. Right now, if I were to send the same programming here that I had on that other board, this would start to light up.
Okay.
Yeah, but that's all it is. So I am taking the same voltage off of the Arduino that I'm giving it through the USB port.
Right.
It's really not more complicated than that, folks.